Hello, Valeron Tan from SMA to IPAB, and from this time I'm going to explain to you briefly about acids and bases. Acids and bases. For this, we have the table of contents. For the first part, we have definitions, which is the definitions of acids and bases. For the second part, we have properties, which includes properties of acids and bases. For the third, we have reactions, which involves around the chemical reactions involving acids and bases. For the last one, we have calculations, which is the chemical calculations on acids and bases. For definitions, of acids and bases, I will use the general definition for this one. There will be 3 more definitions according to each of the scientists, but for this, we will use the definition of the general. For the general definition of acids, acids are substances that are acidic and sour in taste, and also can turn blue litmus paper into red litmus paper, which has the pH amount of 1 to 6.9. For bases are substances that are bitter in taste and also can turn red litmus paper into blue, which has a pH amount of 7.1 to 14. And this one, BRA, is actually, which means that if a blue litmus paper turns into red, this is actually an acid. For RBB, which stands for red to blue equals to base, this means that if you place a red litmus paper and it turns into blue, this means that the substance is a base. Which as you can see, if a blue litmus paper turns into red, which is an acid, and if a red litmus paper turns into blue, it's a base. And the pH scale from 1 to 14. For 7, it is neutral because it is between acid and base. 1 to 6 is acid, 8 to 14 is a base. According to Svante Arrhenius, which makes the Arrhenius theory, acid is a substance that produces hydrogen ion when dissolved in water. For example, as you can see, hydrogen chloride in aqueous solution, it will become hydrogen ion and chloride ion. A base is a substance that produces hydroxide ion when dissolved into water. As you can see from the example, sodium hydroxide, it will become sodium and hydroxide ion. From Johannes Nicolaus Bronsted and Thomas Martin Lowry, which makes the Bronsted-Lowry theory. For the Bronsted-Lowry theory, acid is a substance that can donate protons, while base is a substance that can accept protons. For example, HCl plus H2O equals, which becomes Cl plus H3O plus. As you can see, the HCl is the acid, while the H2O is the base. The reason for this is because that from here, HCl into Cl negative and negative. The chlorine for this donated proton to the H3O solution, which makes it a positive, while the H2O here accepted the protons from the HCl, which makes the chlorine negative. For the last theory, we have the theory from Gilbert and Lewis, which makes the Lewis theory. For the Lewis theory, an acid is a substance that can accept electrons, while a base is a substance that donates electrons. Actually, the Bronsted-Lowry theory and the Lewis theory is almost the same, but the Lewis theory is more correct because the protons doesn't move, but the electron that moves. For example, from you see CaO plus CO2, it will become like this. The CaO is a base, while the CO2 is the acid. This is because the acids from the CO2 here receive the electron from the CaO, which makes this a base and this is an acid. The properties of acid. For the properties of acid, There are 6. For the first one, aqueous solutions of acids are electrolytes, meaning that they can conduct an electrical current. For the second one, we have acids have authorities. Then acids can change the blue litmus into red, and phenolphthalein into colorless. And then the acids have a pH value of 0 to 6. Acids react with active metals to yield hydrogen gas. And the last one is acids react with bases to produce a salt compound and the water. For properties of bases, the first one, aqueous solution of bases are also electrolytes. And then bases often have a bitter taste. Bases change the litmus to blue, from red to blue, and phenolphthalein turns into pink. The bases usually have the pH value of 8 to 14. Bases do not react with metals in the ways that acids do, and the last property is that bases react with acid to produce a salt and water, which is basically the same because they need to react. And for reactions, we have 8 kinds of reaction. For the first one, it is reaction of acid with a reactive metal. The reaction of acid with a reactive metal is the reaction of metal plus acid, which forms salt plus hydrogen gases. For example, this magnesium plus hydrogen sulfide equals to magnesium sulfide plus hydrogen gas. And then copper plus H3, and this yields no reaction. For the second reaction, we have the reaction of acid with carbonates. For this one, it is actually the carbonate plus acid. This reaction will form salt plus water plus carbon dioxide. For example, this calcium carbonate plus hydrochloric acid, which will form this calcium chloride salt plus the water plus carbon dioxide. For the third reaction, we have reaction of acid with bicarbonates. This reaction is basically the same with this reaction with carbonates, but the carbonate is changed into bicarbonate. For example, this reaction below. For the number 4 reaction, we have reaction of acid with metallic oxide. The reaction of metallic oxide is a reaction between metallic oxide plus acid, which will yield salt plus water. In example, this is the example of the reaction. For the 5th reaction, we have reaction of acid with metallic hydroxide. This reaction is a reaction between metallic hydroxide plus acid, which will yield salt plus water. This is the example for the reaction. For neutralization reaction, this is actually a reaction which involves acid and base together, which will form salt plus water. For example, this hydrogen plus OH, which will form water in liquids. 7th reaction, we have reaction of base with ammonium salt. This reaction actually involves ammonium salt and base together, which will form a salt with water and ammonia gas. This is the example of the reaction. And the last is reaction of base with a metal salt. For the reaction of base with a metal salt, we will have a reaction between the first salt in this reaction plus a base, which will form the second salt and a metallic hydroxide. This is an example. And then for calculations. For calculation, there are actually 5 types of calculations for now that I will explain. The first calculation is numbers of replaceable ions. It refers to the total positive and negative charge of the ions that compose the compound. For example, for hydrochloric acid, which is HCl, it has one replaceable ion. For the unit that we will use EQ over mole. And for sulfuric acid, which is H2SO4, this will have 2 number of replaceable ions. For the third one, we have aluminum hydroxide. which is AlOH3, which has three numbers of replaceable ion. And last one, we have magnesium sulfate, which is Mg3PO42, which has six number of replaceable ions. The number of replaceable ions actually come from the fact that the hydrogen in here has one, while this chlorine is one, H is two, while this one is also one. Actually, this one comes from the fact that 1 times 1 is equals to 1, 2 times 1 equals to, and so on, so forth. For the second one, we have equivalent mass. It refers to the ratio between the relative mass of a given substance and its number of replaceable ion. The formula for the equivalent mass, which is equals to EQ, is equal to the molar mass. Molar mass equals to the number of replaceable ions. The unit for this is G over EQ. For example, number 1, we were asked to find the equivalent mass of calcium nitrate. First, we find the molar mass, which is equals to 164 grams over mole. The number of replaceable ions for this is actually Ca, which is 1, and this NO3, which is 2, which is two numbers. Two number of replaceable ion. Then 164 divided by 2, which is equals to 82 G over EQ. For the third one, we have number of equivalents. It refers to the ratio between the given mass of a substance and its equivalent mass. For this, the formula is equals to mass over the equivalent mass of this. Example, we need to find the number of equivalents of 20.5 grams of barium hydroxide. Barium hydroxide is BaOH2, which we will find the molar mass, which equals to 171 grams over mole. For the number of replaceable ions is 2. And then first we need to find the equivalent mass, which is equals to 171 divided by 2, which equals to 85.5, but we round it out into 86. And then we get the mass and divide it with the equivalent mass, which we will get 0.238 number of equivalents. For the fourth one, we have normality. The normality refers to the number of equivalents of solid per liter of a solution. The formula for this is normality is equals to number of equivalent over the volume of solution in liters. And last but not least, we have the molarity. The molarity refers to the number of moles of solid per liter of the solution. The formula for the molarity M is equals to the number of moles, which is N, over the liter of the solution, the volume of the solution in liters. The unit is mole over liter. For the derivation, the normality, which is equals to number of equivalents over volume, which we will get the normality equals to molarity times the number of replaceable ions. For example question, for number 1, this is about normality. For example 1, calculate the normality of a 500 milliliter solution made by dissolving 200 grams of sulfuric acid in water. The given is 0.5 liters for the volume. The mass is 200 grams. And we need to find the normality. For the normality, the formula is number of equivalents over volume. Then we need to find the equivalent, the molar mass and the number of replaceable ions, which we will need to find equivalent mass, which equals to 98 over 2, which is equal to 49. The number of equivalents is equal to mass over the equivalent mass, which is 200 over 49 equals to 4.82. And for the normality, we put this number of equivalent, which is 4.082, over the volume, which is 0.5. And we will get the normality is 8.164 equivalent per liter over or N. For the molarity, it is asked that what is the molarity of each solution. For this solution, 0.25 mole of sodium chloride in 300 milliliters of solution. For molarity, is the number of solute over the volume of solute. For molarity, the M will be equals to 25 over 0.25 over 0.3 liters because it needs to be in liter, which we will get 0.83 molarity M. That's it for the presentation. Thank you very much.